Hello, everyone, and welcome to this session on DevSecOps by Intellipaat. DevSecOps is the seamless integration of security testing and protection throughout the software development and development lifecycle. The goal is to seamlessly integrate security into our continuous integration and continuous delivery pipeline in both pre production and production environments. In this session, you will learn all about DevSecOps and their operations. So, let's start the session. But before we begin the session, make sure to subscribe to our channel and press the bell icon so that you'll never miss any update from us.
Let's talk about the SOC program. The landscape has changed as compared to earlier. As per the existing landscape, you don't have to just deal with the corporate network, but you have to deal with plenty of other gadgets around that can intrude into your network. So you'll have to deal with people's phones. You will have to deal with smart TVs, IoT systems. You'll have to deal with any of the smart devices, those IoT devices. So the point is, there are numerous endpoints to manage. Okay, there are numerous endpoints, and you have the ability to collect data from numerous endpoints. For instance, collecting logs from firewall, collecting logs from many sources. So this is the initial part of it. So the real challenge is you're getting data from multiple sources. How do you manage it? How do you maintain accountability over the fact that somebody might be trying to access your resources, maybe trying to access your resources, and you got to be aware of what is the content in your log files. That becomes really paramount and important. The biggest challenge is that there are too many devices to manage at this point in time. So there are too many devices to manage, and there are numerous point-to-point solutions. That does not help. So you don't have a single. We do have some alternatives here, but most of the security solutions, they are point-to-point solutions. They don't have compatibility with each other. The other factor is these point-to-point solutions, they all work in silos. So whether it's your antivirus, your firewall, your IDS, IPS, your SSO tools, and all those things, they work in silos. Now there are also all the users are generating millions and billions of messages daily. So scanning through each one of them becomes really challenging. And your cyber attacks are becoming more frequent and sophisticated. And your regulatory compliance issues, places are increasing. That's placing additional burden on systems and network administrators. So this is the current security landscape. This is where there are many challenges to talk about. And from a resource capability point of view, a person could be an expert in firewalls, but may not be an expert in dealing with IDS and IPS systems. We have to take into account all these factors. So this is the current security landscape, and most organizations they're not prepared to deal with intrusions and security incidents. They are just not in that position to either deal with intrusions or deal with security incidents. Most of the organizations are addressing issues only after a serious breach occurs. So only after a serious breach has happened, then only they are able to address these issues. Now the pertinent question is, when an incident happens, how are the decisions being made? The decisions are being made in haste. You, at that point in time, when you're facing an escalated issue and it's hampering your production server, it's at the breaking point, you will be forced to take decisions which can turn out to be fruitful or can turn out to be disastrous. So when an incident occurs, any decisions that are being made, they're made in a hurry, which reduces ability to understand the extent and the source of incident, protect sensitive data contained on systems, protect systems, networks, and their ability to continue operating as intended and recover systems. So that's the whole idea. Whenever an incident occurs, all the decisions are made in rash, and there are bound to be certain consequences as a result of the decision that an individual may have taken. You will not now. There is no accountability in such case for incident investigation, protecting sensitive data contained on systems, and protecting systems and networks and their ability to continue operating as intended and recovering. So these are some of the initial challenges. Now, what is the current SOC landscape, Security Operations Center? So let's talk about what has happened in the recent years. In recent years, the complexity of managing a SOC has increased exponentially. Security operations is not just about perimeter. So security operations is not just about the perimeter, which is protecting the edge just outside the company's premises. Just you may deploy a firewall that will provide some level of protection. So that kind of threat vector has changed. Okay? Most organizations are addressing these scenarios, security incidents, only after serious issues happen. And whenever an incident happens, what kind of decisions are being made? Are they being made in an effective way, or are they made in haste? Generally, it's all the decisions that whenever there's an incident occurring, any decisions are made in haste, and that will reduce the ability of the security team to understand the extent and source of incident, to protect sensitive data contained on systems and systems and networks, protect systems or networks and their ability to continue operating as intended and recovering systems. So Daniel says that it's been visible, it doesn't change. Okay. So I hope it has changed now. So for people now, it has changed. Now we're talking about the current SOC landscape. You could enter a Y on chat if you're able to see the slide. Current SOC landscape. Okay, let's see the responses. Okay. So as a part of the current SOC landscape, where we are right. So in recent years, the complexity of managing a security operations center has increased exponentially. And security operations is just not about perimeter security. You don't have to now think about just about your protecting your firewall and that will manage every user in the system. It doesn't work that way any longer. That narrative has changed a long time back. People can access your systems through their mobile phone. You can connect to a VPN and get through all of those. You can get through all those factors and access something. And even there is a potential that if your system has been infected by a malware, that malware, once you connect via VPN to your company's premises, you yourself may introduce the malware in other companies' systems or servers. So, as a matter of fact, security operations is just no longer about perimeter threats anymore. So, security operations does not deal with perimeter threats anymore. There are hundreds of event sources. So you could talk about firewalls, IPS, IDS, proxy information applications, identity management solutions, database, routers, switches, physical security services, merchant or any online e-commerce merchant slash PCCI, all of those things. Those things are, they no longer deal with, or these things are no longer done, by just protecting your the perimeter area. Security operation centers are aggregation points of tens of millions of daily events that must be monitored, logged, analyzed, and correlated. So, in essence, what we are talking about here is all the event sources, centralize all your logs, put it in a single repository from where you could start reviewing the logs, you could start monitoring the logs, you could start analyzing the logs, you could start correlating the logs. So, that's the whole idea. Now comes the important point. What exactly is the SOC? It's a facility that houses an information security team responsible for monitoring and analyzing a company's security posture on an ongoing basis. So this is exactly what a security operations team does. So it's a dedicated setup, first of all, and your security team, would be responsible for monitoring and analyzing organization security posture on a daily and ongoing basis. So like you see on the left hand side, there are certain charts and diagrams. You can see something marked in green. Those are your security chart graphs. And this is how these guys are sitting here as a part of the SOC team who are doing continuously observations around the clock. What the SOC team, what's the goal of the SOC team? It's to detect, analyze, and respond to cybersecurity incidents using a combination of technology solutions and a strong set of processes. Now, see, the narrative also has changed from the past decade. We're talking about SOC, and I'll go back to the full screen mode for explaining what's there on the right hand side of the diagram because it may not be visible, and we'll come back to this part again. But for the moment, let's talk about what's the goal of the SOC team, what it does, what's the goal of the SOC team, why is it about detection? Why not getting malware or any such things out of the equation altogether? Why not? So that is doable. Okay, but the whole idea here is that the SOC team is there to while you don't want any threats to come into your system, you got to make sure that there's a team available who can respond to such scenarios when they face a real threat. So the SOC team's major goal is to detect, analyze, and respond to cybersecurity incidents using a combination of technology solutions and a strong set of processes. That's the whole idea. Who are from a governance point of view? What are the components here? You have people, process, and technology. So you train people, give them training on cybersecurity. You train them on your SOC related tools, and then you establish a process whereby establish a dedicated process whereby the SOC team will be responsible for detecting any security threats, containing them, analyzing them, mitigating them, and all the such things. And if there are any gaps, what are the lessons learned? So that's from a process point of view. And from technology point of view, what are the controls that you're deploying? Are you having a network monitoring, or are you usually receiving threat intelligence? Are you having IDS or IPS? Are you having any other web application firewall, SIM tools, CASB solutions, DLP? So there can be tons of any such solutions. So all of them are a part of the technological landscape. So SOC is a combination of three areas: people, processes, and technology. Now you can see here in the diagram, we have a customer here on the right hand side. We have the SOC team, and then there's a technological landscape where Splunk is used as a SIM tool. These guys are monitoring it. There is an incident handler, there's a customer, So here the customer has escalated the issue, and appropriate responses are being provided by the SOC team. And then the eventually, with the help of the incident handler, along with customer, the case gets closed. So it's a combination of process, technology, and people. That's SOC. That is what SOC is all about. Now, security operation centers are typically staffed with security analysts and engineers, as well as managers who oversee security operations. So, what are the things that you do here? You do log collection, you aggregate logs from various sources, put those things in your SIM tool, have a ticketing system for receiving any tickets, provide threat intelligence feeds, reporting of any security related misconfigurations or any threats, and for research and development. So this is what these are the areas where it will provide some visibility to the top management as to what all the things that are formulated in a SOC in places where there is no SOC team. So you want to establish something, you got to pitch in the right kind of areas that will help a company to establish a SOC structure. And why are we getting this? Why are we doing correlation of all these? Because it is easier to process them at one place rather than requesting other systems, for some dependencies and all those kind of things. So this is what your SOC is all about. You aggregate and correlate the logs that you have collected, all the logs that are coming from different places. They're all going to a centralized repository, centralized location, and which is your Azure storage. And all the logs are getting correlated there. So you might keep them for 3 months, 6 months, or even longer than that. Depends on what the organization policy is. Now the question is, why do you need the SOC? Because having just an firewall and IPS are not enough. You need to provide continuous prevention, protection, detection, response capabilities against threats, remotely exploitable vulnerabilities, and real-time incidents on your networks. You work with a cyber incident response team to create comprehensive infrastructure or managing security operations. So this is why you would need SOC, because just having a firewall and IPS will not do the job. You need to have the tools that can provide continuous prevention, continuous protection, continuous detection capabilities, and response capabilities against threats, remotely exploitable vulnerabilities, and real-time incidents on your networks. This is why you would need SOC. What are the benefits of SOC? Speed of response time. Malware can spread throughout the internet in a minute or even seconds, potentially knocking out your network or slowing traffic to a crawl. Subsequently, each second counts in identifying these attacks and negating them before they can cause damage. Your ability to recover from a DDoS attack in a reasonable amount of time, that can be done by your SOC team. So your SOC team primarily is responsible for the overall security-related troubleshooting or any security deployments that are generally carried out by the SOC team in tandem with inputs coming from the CISO. These are some of the benefits. And then what are the components of SOC? What would formulate, what are the things that will formulate within the SOC? So to build the SOC with simple acceptance and execution model, maximize the use of technology. Remember, there were three pillars: technology, people, and processes. So to build security intelligence and visibility that was previously unknown, build effective coordination and response unit, and to introduce automation of security process, develop SOC processes that are in line to industry best practices and accepted standards like ISO 27001, PCCI DSS, IEC 624443, and NIST. So to build the SOC, you should first start with a very frugal approach, simple acceptance and execution model. See how that goes, and if all looks good, then start getting the other systems in line with the SOC. What are the key successes of SOC? So it's people, technology, processes. People can be part of virtual teams, and they will generally carry a high skill set. Technology, so you look into various emerging technologies. You would need to carry out a dynamic risk assessment. You may need to perform a network forensics and analytics. And from a process point of view, from a process perspective, business process orientation would be provided, and comprehensive compliance and incident response. That is also a part of the process as well. What are the four components of SOC? You basically have an operational support system. You would have a SIM tool, which is a security information and event management tool, which can monitor for any such threats and can detect them. Proactive monitoring, network and security and server infrastructure, alert and notification, security incident reporting, and if there are any if there are any events that require correlation. So event correlation and heuristics, behavioral anomaly, that all is a part of your SOC core components. So as a part of proactive monitoring, what are the things that you can monitor? It's designed for threat hunting. It is designed for getting the reportings, set up alerts, to detect threats, how to respond to attacks. Then the next thing could be to how to stop such attacks from further damaging a company or tarnishing a government's reputation. SOC is all about looking into all the technical aspects. It's more on the technical aspects. It's more on the implementation. It's more on the technical aspects related to cybersecurity. So you have different levels. You have L1, L2, L3. So you have different SOC layers as well. The whole idea here is that the SOC team is responsible for all these functions.
Just a quick info, guys. If you want to make a career in cloud and DevOps, then Intellipaat provides an advanced certification in cloud computing and DevOps by ENICT Academy IIT Roorkee, and it is taught by IIT Roorkee professors and industry experts. This course is designed to help you upskill and land in your dream job. Now, let's continue with the session.
They are the ones who are responsible. This log collection aggregation that may work out for SIM tools, but there are other things also which a SOC team does. They may be involved in configuring rules in IDS. So the multiple responsibilities fall under the SOC team. You may dedicate a small chunk of professionals to somebody, maybe a expert with a SIM tool. So that's deployed. That resources taking care of that. Some person may be an expert on web application firewalls. So that person's goal is to harden the security of that web application firewall. So this is how your SOC team would actually work. It can also work remotely, whereby you can have certain discussions with your team, internal discussions regarding how to go about this or how to set this up. So those are the kind of questions that, and when we come towards, we'll come towards either today or tomorrow, where we'll talk about the responsibilities that a SOC team carries out. What are the requirements that they really carry out. Your attacker will just go ahead and attack your systems. The SOC team will be responsible for detecting those threats. First of all, the SOC team will be responsible for making sure that this system disrupted from the network, because this scenario could affect other systems if it continues for long. And by doing that, they eliminated all this. Now, what are the critical core components of SOC? You have operational support system. You have a SIM tool, which is your security information management system. You do proactive monitoring, network and security and server infrastructure, alerts and notifications, which is a part of security incident reporting, and events correlation and heuristic behavior. Now, as a part of your proactive monitoring, you can see at the bottom you have automated monitoring via SNMP. You can do categorization of monitored objects, and notification. You can get automated alerts and notifications via SNMP traps or any such events. Alerts are categorized based on risk level, and notification is generally sent out to business process owner. Event correlation, contextual correlation of events, situational awareness, and this is mapped to business process. So these are the typical components here. And then you are doing things such as information network security automation to natively built in compliance and audit functions, to manage control process through integrated ITIL version 3, configuration management, and configuration management of the infrastructure components. Now, as a part of the compliance and audit, what are the things that they provide? Compliance templates creation, compliance enforcement, compliance reporting, compliance violation reporting, change management, device change management process, automated approval process linked to compliance template, follows change control validation and change management history log. And as a part of your configuration management, you configure archival storage. Configuration change is mapped to change control, configuration management database, and which contains a complete history of archive configuration. That is what your Oracle database that's there that stores all this. Now, alignment of risk management with business needs. This is very much needed. So you want to make sure that you align your risk management with the business needs. Qualified risk ranking. So you want to make sure that risks are ranked based on business impact analysis. That there is something called as business impact analysis sheet. Okay, some part I've already run through it. I need to update this part for we ran through this part. So let's understand what are the core components here. So who are the participants? What was the date? Who's the unit manager, phone number, and all that stuff. That's the initial part of your business impact analysis. What all things does it capture? To identify the business processes and prioritize them according to criticality, to identify the recovery time and RTO and RPO, to identify key computer systems, equipment, and applications associated with each business process, to identify the quantitative and qualitative impacts that will be incurred should a disruption occur, to identify critical interdependencies associated with the business unit and their processes. So for the purpose of answering DI questions, we are taking into account worst case scenario, any DR scenario, all those things. Now, if we go across this part, RTO is recovery time objective, RPO is recovery point objective. So that's a definition of RTO and RPO. And whenever during 24 hours of the day, whenever if your server goes down for any reason during the weekday, then you're facing a challenging scenario. You have to recover, restore, and recover your database. All those things you'll have to do that. So you'll have to do all the hard yards. And then you also want to make sure that the recovery of the failed system is done within the RTO time frame. So when I say recovery time of recovery time objective, it simply refers to the amount of time that a system will be down, and beyond which it will resume operations either from the primary site or from the secondary site, which acted as a primary site during the time when certain people were away. So RTO value should be definitely be low because you want to recover as soon as possible. So RTO value definitely has to be low. So you got to restore from backups and make sure that is as low as possible. Now, when it comes to RPO, recovery point objective, that also should be low. And the reason for RPO value should be low is because recovery point object, you don't want to lose data. There will be data loss if you continue with. So let's say my RPO value is 1 hour. So it simply means that whenever I restore from backup, I'm willing to lose up to 1 hour of data. That's the whole thing. So the business unit name, what is the business unit name? Providing a brief function of your business unit. What are the unit's normal work hours? How many people are working in that department? What is the average work volume? Example, number of business registered, number of audits completed, number of timesheets entered, etc. processed by the unit. So we are saying 5,000 units on 5,000 orders on an average. Where applicable, relate work volume mentioned above $2 of value. Does the unit have a peak volume or any other critical time frames? If yes, when these happens? So we mentioned here operations are 24/7 and any mutual fund orders can be placed at any time. Market trends can affect the behavior. So this is what exactly it is. So you have to specify your key business processes. You will have to specify your RTO, RPO. And is this being done manually or is it automated? If it's done manually, for how long? If automated, how's the assessment going? And what are the computer systems or applications required to perform this process? Those are also some of the things that we'll document. So once you are through with the key business process, the next part comes to your quantitative and qualitative impact estimates. Now, they have chosen a numbering system whereby low range and high range is given, and the qualitative impact test related things. Now, you can do a risk assessment from quantitative to qualitative. What we have done is we have done for qualitative, we have not done for quantitative. So, what are the things that we have taken into account? Degraded customer service. So, if during 24 hours the service is not restored, then the impact would be 3. 3 means moderate to high. If the instance is not being fixed or a solution is not provided within 24 hours, then it is high to catastrophic. That's the and for 1 week and beyond 1 week also these numbers remain similar. Non-compliance with government regulations, so you have the impact for 0 to 12 hours. Degraded quality of work, non-compliance with contracts and SLAs, loss of stakeholder confidence, delayed delivery of internal products and services. So you go through this part and then you come towards the final section, which is the identification of regulatory, legal, and service level requirements. So how do you identify the legal or service level requirements? So you want to give what is the impact of key business process, and if anything is getting affected from a legal standpoint or from a regulatory standpoint, you got to document that. And so this part is about identification of regulatory, legal, or service level requirements. Now, business units, interdependencies. What is the business process, receiving and sending the work, type of work, you receive from whom, which business unit, and so on. So this is all related to if there are any business unit interdependencies. Identification of vital records. A vital record is any information required to support key business processes and daily operations. Vital records are essential to the operations and recovery of a business unit, division, or business location. They can be in many forms. Example, tape drives, CD-ROMs, hard copies, reference material. So you can provide all those things. And then point number 7 would be, what are the potential changes anticipated over the next 12 months? So what anticipated changes could affect business impact identified above. When answering, consider the new federal state regulations, reorganizations, computer systems, networks, etc., changes to distribution network, and new business partnerships. And how would financial and operational business impact change under any of these above conditions? So you've got to consider budgets, lost revenue, employee morale, stakeholder confidence. And if there are any other important discussions that can be addressed here, and any manual process can be mentioned here. And then finally, you come towards the end of this. So this is a template that is used for business impact assessments. Okay? This is the template that you use for business impact assessments. Now, what was the first generation SOC? This first generation SOC was between 1975 to 1995. It was a time when internet during this phase was just born. So the duration of this session would be from under 20 minutes, and then we'll wind up for the day. Under 20 minutes, and then we'll wind up. So the duration is generally between 9 to 11. Now, what is the first generation SOC? It ran through 1975 and 1995. It was a time when internet was just born. Businesses were not that connected, and if they were connected via very slow connections, and there were some of the programs were carrying a lot of nuisance, and it was easy to it was easy to import malicious code on other systems. And this was a time when the military and the governments started to build security operations center and computer emergency response teams. This is the time that during this time frame they started all this. Now let's talk about the second generation SOC that ran through the years between 1996 and 2001. Now malware, it is a time when people became familiar with the fact that their malware could also spread. Now, so how do we stop the malware? So malware outbreaks and intrusion detections that's been happening all the time. Nowadays, managed service providers begin to offer SOC as a service to customers, and SIM concepts are introduced there. So this was the time frame between 1996 to 2001. And then you have a third generation SOC between 2000 that ran through between 2002 and 2005. Now here there were some subtle changes. You introduced botnets. Botnets came here. Cybercrime increased during these time frames. Intrusion prevention and compliance capability were enhanced. And large companies in specific industries were creating internal SOC teams. So that was the time period between 2002 and 2005. And the fourth generation, which started from 2006 onwards until ran till probably 2012. So here, hacktivism, intellectual property theft, advanced persistent threats started becoming more well known. So wide adoption of continuous security monitoring as breach fill headlines. So this fourth generation SOC improvised a lot of things further. So earlier it was dealing with a new kind of malware that can change its perception, that can change its form. So that malware, dealing with that kind of scenario could only be done by the fourth generation SOC team in US, or fourth generation or higher than that. Now fifth generation does subtle, which started from 2013. It does subtle threat detection. It can do threat hunting, can provide counterintelligence. It is anti-fragile, and it uses advanced analytics and big data. So security operations maturity model. So you have 5 levels similar to what are there for your CMMI, which is for software engineering. You have 5 models here. Level 0 is incomplete. Here, operational elements do not exist. Level 1 is performed. So there is a minimum compliance requirements to provide security monitoring are being met. Level 2 is managed. So here, business goals are met and operational tasks are repeated. Level 3 is defined. Here, operations are well defined, subjectively evaluated and flexible. Level 4 is measured. Operations are quantitatively evaluated, reviewed consistently, and proactively improved. And level 5 is optimizing. Here, the focus is on operational, it's an operational improvement program that has been implemented to track any deficiencies and ensure all lessons learned, focusing on continual improvements. So level 0 is incomplete, where there is no process, nothing. Level 1, they have some structure in place. At least they're doing the bare minimum compliance requirements. They're satisfying that need. Level 2 is managed. Here, business goals are met and operational tasks are being done in a repeated way. Level 3 is defined. Here, operations are well defined, subjectively evaluated, and flexible. Level 4 is measured. Here, operations are quantitatively evaluated. So your operations are, they do well in level 4 also, but they're further evaluated for achieving further excellence, reviewing consistently and proactively improving. Level 5 is optimizing. It's an operational improvement program that has been implemented to track any deficiencies and ensure that all lessons learned learn continual drive improvement. Now let's talk about incident response handling. Now the focus area of the core focus, as you know, for security operations center is not about just about they're not there to prevent something. Their whole goal is to detect something. So they want to showcase that they're effective as a team. So as a part of your incident response handling, how effectively the SOC is measured by how many incidents are managed, handled, administered, remediated, and isolated. And there's a continuous cyclic feedback mechanism that drives incident response handling. Critical functions include network forensics and surveillance technologies. You reconstruct the incident, evidence gathering, effective investigation, and escalation management. Know who to communicate during an incident. So it's very important that when there is a actual breach or when there's actual something that has happened, so you have to take into account various factors. You want to take into account whether you will be able to provide the evidence when needed, when if you're doing evidence gathering and investigation, and you should also be aware as to whom to escalate the issue within. Even if it is outsourced, you should have a point of contact to make sure that who so identify the person who will be responsible for this. And the core functions of core components include network forensics and any surveillance technologies. Now, as a part of incident response, they do network forensics, they do escalation management. As a part of behavioral analysis, they do network behavioral analysis detection, they do anomaly detection, they do predictive analysis, and finally, they do business process profiling. Reporting, it's based on incident feedback and review process. Prosecution, could be because of disciplinary reasons, could be because of any litigations. So the whole idea here with SOC core components is that your incident response handling is the major thing that drives this. And the sooner it gets, the better it will. And the critical functions are definitely network forensics and surveillance technologies, because with the help of network forensics, you can discover if there are any, even before any such packets are getting routed, you can block it at that layer itself. How do you integrate all these core components? Let's just try and understand how these core components are interrelated. Okay, we have a few pointers on chat. Let's take a look. This is the, entire topic is all about this course, right? Security Operations Center, this is the entire, the course is on these lines itself. So I'll have to, talk about it, right? Anyways, that's fine. If somebody is, that's okay. So what we are talking about is how do we integrate the core components, data collection, event correlation. So you can see here that there are various areas here. Integration of core components. So you have, if you look at this slide, you have multiple areas, right? You have your service desk, you perform, you do VAPT, you do monitoring. So in various places, you would have various kind of things. For instance, you may have deployed a Solarwinds solution, Arian or something like that. And so that will be capturing the logs from various sources, and it will be sending across, a particular location. All those logs will be shipped across to a particular location, and you will correlate all these logs. Your whole idea is to correlate all these logs, get them in one location, analyze them, understand all these core logs, evaluate these logs, and see if there are any threat vectors there. So, for example, because across a given organization, take for example, there is a single organization which is having up to 1,000 employees in 2 locations, and you want to make sure that all the information that is coming from their applications, from their critical infrastructure, is all those details that are coming from the critical infrastructure, all those logs are shipped. You get them in a centralized location, you analyze them, analyze the information there, and find any traces of any active threats that may be occurring. So that is one part of it, shipping the logs. The other part of it is vulnerability assessment. So you may have certain vulnerabilities in your servers or something. So you want to make sure that those things are addressed in a timely fashion. What do? You patch your systems, you make them up to date, and you continuously monitor for any threats, any such further threats. That's the whole idea. So the one part of it is, completely you're doing VAPT assessments, you're getting the logs from all the places, you're getting the logs from multiple sources, you get them in one place, you correlate them. At the same time, that's one part of it. The other part is you do VAPT, you also make sure that if you have to maintain compliance with any of standards, those risks are remediated. You focus on all of those things. You're using SIM tools, okay? Because why SIM is an essential component of this is because you're getting all the logs in one location, you're correlating them, and that's how you're addressing. So it helps you to meet the compliance and management requirements. That's the whole idea. And then you would be managing other components like WAF and all those kind of things. WAF, firewall, all of them are a part of your these tools. The SIM tools. Sorry, all of these exercises are a part of your security operations center. So typical technologies, what you use here, you use SIM solutions. You have Azure Sentinel, you have IBM QRadar, you have multiple things. You are collecting events like events from your log files, syslogs, SMB, OD database logs, all log. You are collecting all log sources. You are also collecting all flow collections. You have an asset database where it's based on asset criticality, risk and vulnerability, system and business owner. You are maintaining track of that, along with the fact that you are since you're getting the events and flows, you are going to correlate them. You will put that information over the dashboard if you see certain threats there, and you have a centralized console for your security dashboard and reporting. So you're doing all those things. And you may also integrate with service desk for automated ticket creation and all those things. As a part of compliance management and policy confirmations, configuration audit across infrastructure systems and devices, ISO 27001 related security compliance or PCCI DSS, risk management, identification and mitigation, baseline configuration, all of these things we are doing right here. So you're also doing things like network and security monitoring. For example, I just talked about SolarWinds performance monitor. So you're capturing metrics like network monitoring, link utilization, availability monitoring, SLA reporting, and then you are also doing things like security analysis and threat intelligence. You're doing network forensics, collecting artifacts and packet reconstruction, monitoring all internet activity. You are also, getting threat intelligence. All of those things you are focusing your areas. We are talking now about this blue team, red team, and the purple team. Okay, this is what we've been talking about. Now let's understand when you need to build up a SOC, what all the kind of technologies you will deploy as on the security side of things. And mind you, we are not dealing with just the network security part of it or the web application security. We are talking about a range of new technologies. We're talking about IoT, we are talking about cloud security. So what are the kind of tools that we would need? What are the kind of tools that an organization would need? So let's talk about that first. So you would definitely need something like a next generation firewall. This is what you would need. This is definitely the need. And then we'll talk about each of these individual components. You would need a next generation anti-malware. This is what you would require. You would need a web application firewall. Okay. You would need a SIM tool, which is security and event management. Okay. You would need a SIM tool. Okay. What are the other things that you will need apart from these? You would need a DLP, a data loss prevention tool, DLP, data loss prevention tool. You would need file integrity monitoring software. Okay, you would need this. See, what we are trying to talk about is the length and the breadth of the kind of security technologies that you would deploy in a SOC. So you would you will go with next generation firewall, a next generation anti-malware, a web application firewall, a SIM tool, a DLP tool, a file integrity monitoring software. Okay, you would also go with a network monitoring software that would be definitely required. What are the other things that you would need? You might need something you might require an email gateway. Okay, you will definitely require this. Let's see some other things. Yep, you would need a intrusion detection system. That is what you would need. You would need an intrusion detection system, and you would require a IDS, intrusion prevention system. So this is what you would need, intrusion prevention system. So we're talking about the different kinds of security controls that would be required in a SOC environment. What are the kind of things that you would need? You would need to work with a cloud access security broker. What else you would need apart from this? So you've deployed all of these topologies. If you're working with cloud, you would need a cloud security posture management tool. Okay. You would need, for your SaaS applications, you would probably require a SaaS security posture management tool. So I've kind of listed a range of services or a range of different spheres of areas you would need in a SOC environment. Okay, you would need same tools and all that. Now, what are the next generation firewalls? Yeah, I'm giving an example of coming to that answer. Now, what are the kind of next generation firewalls you would use? You would use something like a Palo Alto. You would need something like a Fortinet. You would use something like a WatchGuard. You would need something like Checkpoint Firewall. And you can also use something like a pfSense. There are more and more firewalls, but I've given you examples of this. What could be the example of a next generation anti-malware? Malware could be Panda AV. It could be Checkpoint Harmony solution. That would work Web application firewall, you have Mod security, you have, which is an open source, web application firewall, by the way. You might use a F5 web application firewall, a FortiWeb, which is from Fortinet. You might use a Barracuda web application firewall, web firewall. So at least I'm giving you various examples of all different. Same tools could be Wazoo, same tools could be QRadar, IBM. Same tools could also be Splunk. You could use Sumo Logic for the same purpose, which is a well-known tool. What else apart from this? Azure Sentinel, which is on cloud. You can use that. See, we are talking about a range of different technologies. Okay, so you can use these tools. Then we talk about a DLP tool, data loss prevention tool. Okay, you can use something called as Komodo DLP. Okay, you can use a Terramind DLP, data loss prevention tool. File integrity monitoring software, one of the most famous is Tripwire. You can use that. Network monitoring tool could be Solarwinds. You could also use Passler network monitor. So you could use this kind of tools. Solarwinds has different kind of tools. Okay, so Solarwinds network performance monitor is what you're going to use. Again, email gateway, you could use Barracuda email gateway. That's very effective. Intrusion detection systems and prevention systems, they work in tandem. So basically, your IDS and IPS, they work in tandem. So you would have, Snort as an example, you would have Suricata as an example. And when we talk about intrusion prevention systems, Snort, Suricata are also intrusion prevention systems. You can talk about Dro, Zeek, they are also examples of that. Cloud access security broker. Okay. Yeah, let's come to those questions. Okay, we'll come to that part. When you talk about cloud access security broker, which could be the one that is effective? We have famous ones are, let's talk about cloud access security broker tools. So you have something from Cloudflare. So you have a Cloudflare CASB, you have Proofpoint. They are well-known CASB tools. Cloud security posture management, you have a well-known tool called as open source tool from Aqua Security. And then there are a variety of SaaS security posture management tools. In fact, one of the best would be Checkpoint SaaS, Checkpoint CloudGuard SaaS. Okay. That is one of the best security monitoring, security posture management tools. Okay. So we have listed a few of them, right? Yeah, even PAS Prisma Access is also in that category. Yeah, BitGlass has been purchased by, I think instead of BitGlass is also purchased by McAfee. So yeah, many kinds of these tools. And the whole idea is which ones are famous, which ones are there in the market. So we have listed out different kind of setups here. Now, from our perspective, these are at least, and there could be more range of technologies, but at least you are dealing with all these kind of setups in your SOC environment. These are the kind of technologies you would definitely find if you're working on the SOC environment. Okay, now the point comes, all these security devices, be it a firewall, be it an anti-malware, be it a WAF, be it a DLP tool, be it a network monitoring software, be it a cloud access security broker tool, any of these things, they all generate logs. Okay, they are generating logs. What they're doing is log generation is one of the core activities of this. As we will start covering the slides on log management today, you will become familiar with why log generation is so important. So you collect your logs from all these security devices. Not only this, you would actually collect your logs from different security logs, from application logs, server logs, all those things, you will collect them. And security team's main goal is analyze the logs. That's the main goal. You analyze the logs for any known threats or any patterns of threat that your organization may be facing at that point in time or in the past, or they may have faced in the past. You would definitely deploy something like this. You can also deploy a DDoS tool, like a DDoS tool. If it is on-premise, you can go with the FortiDDoS tool, which is one of the most popular DDoS tools. So it can prevent your denial of service attacks. Now, not every company has the budget for all these kind of security tools. So in some cases, you end up deploying open source security tools. And for some organizations, you might want to deploy the proprietary softwares. And as a SOC analyst, you should be familiar with at least a couple of tools. You cannot be an expert in all the areas, but if, let's say, if you understand firewall, you understand SIM tools, you understand network monitoring software, you might have had prior experience with IDS or IPS devices. That is you can work with 3 or 4 different areas. You can get an opportunity as a SOC analyst. So that's the thing. So there are different kind of system requirements, friends. If I want to deploy a pfSense firewall, I would need at least more than 8 gigs of RAM. So there is certain different softwares have different requirements, but at least at a bare minimum, I would need 8 GB or more of RAM. I would need that. I might require a bare minimum 4-core processor also. So all these systems and all these firewalls, for example, if we talk about next generation firewall, you got to take into account how many concurrent users can it support. So for example, there's another firewall called by the name of Untangle. Okay. Now, if I go to the Untangle website, and if I talk about next generation firewall, if you go here, it tells you how many range of users can it support. Every firewall, it provides different kind of models, and different firewalls have different, they provide different capabilities. So your specific, some of these firewalls can help, can support up to 500 users, some can support up to 1,000 users. Every of these different systems, okay. For example, we talk about these Z series appliances. You can see here Z4 appliance, which is for a small office or a branch location for Untangle firewall. It can support up to 10 to 50 users. You have a Z4 Plus, that is also in the same limit. But when you go to a mid-sized office or data center, which can support up to 500 to 100 users, you go for this kind of a firewall, Z6. And Z12 can support more than 1,000 users. And so there would be a cap of roughly, let's say, 1,000 to 1,500. And Z20 is up to 3,000 users. You can see that. So there are the whole and sole point is different kinds of security devices have different requirements. You have many variations of them, and that's how you'll get support for each one of them. So we have talked so far about these kind of softwares. Now the essential point is all of these softwares, they generate logs, and your goal is to analyze these logs as a security analyst and see if there are any perceived threats in the environment. And all these logs, you can transport them to a centralized repository. You can send them to cloud storage like S3 buckets, or you can send them to Azure Data Lake or any other such object storage. You can send it there, because object storage can it can provide support for more kind of data. Okay, it can support huge range of data. So that's the idea. So collect all your logs, put them in a centralized repository, and then start analyzing those logs. So you would use tools like SIM tools to analyze those logs. And once you analyze them, you can see what are the perceived threats to your environment. Do you see any perceived threats to your environment? What is your security posture like? As a part of your SOC, when you start working with these security and event management tools, they can start looking for any events, any threatening events in your log files. And then what they will do is, over the dashboard, they will with a graphical visual representation, they will talk about the severity of a scenario of a particular. An alert may get created for a specific threat, and an incident may also be logged. Nowadays, most of these softwares, most of these SIM tools, they have not only you can do threat hunting with them, such as the level of sophistication that for typical kind of security incidents or security alerts, you can provide automated responses. You can provide automated responses for certain category of security events which are common in nature. So these are the kind of things that you do in your SOC environment. Having an understanding of 3 or different components would be essential for anybody to have a successful career as a SOC analyst. So this is one part. Deployment is one part. The other part is, what is the other part apart from deployment? So the other part from deployment is, so vulnerability management is the other part. You look out for threats. You're looking at threats, and your goal is to identify any weaknesses and get them mitigated. Okay, so there is a specific score that gets computed for every asset, and that's the role of the SOC team to remediate any of those risks. Open source SIM tool, the best one is Wazoo. I've already listed Wazoo here. Okay? That is the open source SIM tool. Now, vulnerability management. So your goal is to identify vulnerabilities and get those vulnerabilities sorted out. Okay, so you want to make sure that the vulnerabilities are identified and they are sorted out in due course of time. Monitoring is an essential component. Monitoring for any events, that is the core component of your SOC team. Monitor and report incidents. That's the whole thing. That's the main objective of your SOC environment, of having a dedicated SOC team. So this is, now what are the other things that you do? You do vulnerability management. The next focus is on mitigation of risks, mitigation of existing risks. If you have some existing risks that can be mitigated, okay. Vulnerability management, mitigation of existing risks. That is what we do as a part of your SOC assessment. Then what is the next part? What are the other things? There is a method to it. There is a way to approach all these things. So let's understand that, and then we talk about what are the kind of things we'll cover, and then we'll talk about log management. We talked about vulnerability management. We talked about mitigation of existing risks in the organization. This is what we talk about. What could be the other activities? Monitoring your security devices. Okay, this is what you do. Evaluating the effectiveness of your security controls. That is also a part of the SOC team. Evaluating the how effectiveness of your security controls. That is also a goal of your SOC team. So vulnerability management, mitigation of existing risk, monitoring of security devices, evaluating the effectiveness of security controls. Threat hunting is equally important. So you hunt out for threats that may be, that you may see traces of certain threats almost live. So threat hunting is also a part of this exercise. These are the core activities that is being performed as a part of your overall assessment. Along with this, you perform compliance with your existing, compliance with your existing policies. Every company has, most of the companies, have a chief information security officer who is the primary person who rolls out the security policies and the compliance with your existing security policies. Okay, with your existing security policies, this is the goal of the SOC team. You may, if you are getting certified with ISO 27001 or with any standards, so compliance with existing, industry standards like PCI DSS, ISO 27001, and so on. Participation in internal audits as well as external audits. So you, either somebody from the SOC team or some internal, you formulate a group of members who may carry out internal audits, and you may also be, you may have external auditor who will work with some of your members of the SOC team to see how this overall landscape works. So these are the kind of activities that we do on your SOC environment. Now, what are the kind of threats you may see? You may see the kind of threats that you may see there. What are the kind of threats that you may see in the SOC environment? You might see traces of DOS attacks, DDoS attacks. You might see symptoms of a ransomware attack. You might see a symptom of a ransomware attack, and somebody is trying to cause, let's say, you might definitely see traces of man-in-the-middle attack, MITM, man-in-the-middle attack. You might see traces of this. So these are the kind of threats you might see in your live environment. So DOS attacks, symptoms of ransomware attack or a malware attack, okay, traces of this thing. And the last category would be, one of the last ones would be APT. You might see traces of advanced persistent threats. Now, please understand that every malware that you deal with, every kind of malware that you deal with will not always have a signature, okay? Certain malwares probably may have your environment first, or they are like dealing with, because that is what you're dealing with in case of zero-day attacks. Any malware attacks for which you do not have symptoms, for which you do not have any signatures or patterns, identifying them is also a core activity of your SOC team. Identifying any such advanced persistent, such attacks is also a core element of your security team. So security team, for instance, if you see traffic, what are the use cases? Let's talk about, what are the potential scenarios? For a moment, let's talk about the potential scenarios. Now, for instance, if we have a user called as Ravi K, okay, let's say now if I see this user logging to my application from a place like India, and at the same time I see another instance of this user connecting from Germany, that indicates that there is a potential problem, because a person can physically log in from one place. They cannot be from two different places. You cannot have the same user logging in. It does not make sense. So this is a potential scenario where you see something like this, and you suspect you become suspicious of that. What is the other part? What could be the other potential scenario? Now, let's say at 3 in the morning, you are seeing network traffic to be as high as 90%. When the number of users are almost very low, if you see a network traffic around 90% high, it's an indication of an anomaly. Something is wrong. So identifying anomalies, it's an indication of an anomaly. And identifying such anomalies is the goal of your SOC team. Buffer overflow also, yeah, why not? Buffer overflow attacks, they are a part of, different kinds of, Trojan attacks and malware attacks. So buffer overflow is also part of it. So the potential scenarios that we are seeing here, where if I see two different logins for a single user coming from two different places, it's a potential issue. And at 3 a.m. in the morning, if you're seeing the network traffic to be as high as 90%, when the number of users are very low, it's an indication of some issue happening. And let's talk about another potential scenario where, which could also be, which could indicate a symptom of an attack. Let's talk about another potential scenario apart from this. First one, we already talked about user logging in from two different locations. Second one, network traffic high at a time when there is very low user activity. What could be the other potential scenario? Let's talk about a third potential scenario. Now, these two we have already covered. Let's take a look at what somebody has mentioned there. So the third one could be, if you have a user, you do things like user profiling. Okay. Now, if I have a ETL user, okay, who connects to a database, starts doing ETL operations, extract, transform, and load. And then I suddenly see the ETL user also issuing a shutdown command. Now that's an indication of anomaly. And that is what somebody mentioned in the chat about Ueba tools. This is exactly an example. So you profile your user activities, and if the behavior of an individual user is different from other patterns, so you talk about Ueba tools, this also. And Gurukul is one of the famous ones. You have Gurukul. You also have something from Imperva. So if a ETL user connects to a database and starts doing ETL operations, which is a normal thing. But if a ETL user issues a shutdown command on an Oracle database, it is an anomaly, right? So it's an anomaly. And you got to start investigating why this action was performed, why this kind of action was performed by a user whose core goal is to load operations. Now, this user may have access to running the shutdown command, but it's not his job. It's not the user's job. So that is an indication of an anomaly. Okay, so we have talked about three different scenarios here. Ueba tools, Gurukul and Imperva is one of them. You also have something called as DAM tools, okay, which is known as database activity monitoring tools. And there you have something known as IBM Guardian. You have another tool called as Sunrise Data Security, which can also do the same thing. So they are well-known DAM tools. So these are three different indications of potential scenarios that your SOC team would be interested to investigate. So to add another goal here is to carry out, cybersecurity investigations. That's also the goal of your SOC team, to carry out. If you see certain things, and then another thing is a breach. Let's say a data breach has happened. Incident response is also a part of your activity. So you would, if you suspect a data breach happening, you will take that system off the network. You will analyze all the things. Incident response is also one of the core activities. So these are your typical activities. So these are the typical activities that are performed by your SOC teams. Digital forensics is again the same thing, because when I think it's not too different, because cyber security investigations also include digital investigations also. So that part is actually covered here. When you carry out investigations, digital forensics is a part of it. Okay, so it's not too different. So these are typical activities that are performed by the SOC team, and I'm putting on chat for everyone's reference. Typical activities. So I hope this part is clear to everyone. Any doubts on this, whatever we have talked so far?
Just a quick info, guys. If you want to make a career in cloud and DevOps, then Intellipaat provides an advanced certification in cloud computing and DevOps by ENICT Academy IIT Roorkee, and it is taught by IIT Roorkee professors and industry experts. This course is designed to help you upskill and land in your dream job. Now, let's continue with the session.
These are the typical and the core activities that are performed by your SOC teams. Now today, before we get on to the slides and something else, let's talk about something further here. Okay, please understand a few things further. So how do you carry out these vulnerability assessments? What are you going to do to carry out these vulnerability assessments? How would you do that? How do you maintain all these kind of things? So let's take a look here. For instance, yesterday I talked about a risk assessment. Let's take a look at this. Now this is the data privacy risk register, a similar register you would maintain for your cyber security, for your risks. So for example, do processors ensure data protection by default in all processing activities? So you give what kind of it is, what is the kind of risk source, what is the possibility of reoccurrence, what is the overall impact level, probability of that, what's the probability of that occurring, priority level, and what are the following steps to take in order to eliminate the risks. So for example, there is a scenario that we talked about. Do you maintain policies, security policies and procedures? And are you conducting due diligence on processors and sub-processors? So typically processors, this is an example, processors are all third parties who are in the supply chain and who are accessing your company's data or your customers' data on your behalf. Now, the source is external. Is it ongoing? So which means that this is something that keeps happening all the time. And there is a likelihood of data breach if policies and procedures are not maintained with external parties or partners who access companies' data. That's the thing. And how can this risk be mitigated? This risk can be mitigated by drafting data privacy requirements in contracts with partners and asking the external partners to conduct external data privacy audits in order to identify and remediate any of the data privacy risks. So that is what these are your controls. That's the kind of a control you would apply. This is from a process perspective. If it is anything else, for example, if there is an issue in your operating system, so there could be a system parameter that you might have to change in order to fix a vulnerability, or you might have to patch a system. So these are the kind of registers, risk registers, that your SOC team maintains all the time. And you want to, the end goal is not only monitoring, but to remediate these risks. How to go about remediating this risk. So SOC team has to work in tandem with your application teams. It has to work in tandem with your network team. It has to work in tandem with all the different kinds of people in order to mitigate a vulnerability. So if something can be fixed by the SOC team itself, they will fix it. If they see some traces of a risk, and if the risk can be mitigated by the application team, then they will tell them this parameter or this thing needs to be fixed by you. So this is the kind of risk register you maintain. Now this is for a data privacy. The same could be applied for your cybersecurity internal risk register or external risk register. So this is about risk registers. Now the next question is, we've identified some risks, but participating in security assessments, that's another part. So another activity is participation in security assessments. So these are the kind of activities that you perform. And when we talk about security assessments, okay, let me give you a brief narrative here. So when we talk about security assessments, we go through a series of questionnaires, okay, and that tells us, that gives you a sense of what could be a process related vulnerability. What are the kind of things that could be a process related vulnerability? Giving an example in this area, let's talk about an example of a process related vulnerability. For instance, if I were to do an audit or an assessment of any specific organization's web environment, web application environment, what's the first question you're going to ask them? What's the kind of question that you're going to ask them? The first question that you're going to ask them is, when you move your data, or whenever you perform any changes from, or you introduce new features in your production environment, do you, from UAT, do you carry out a security assessment of the changes every time you deploy code in the production environment? It's a very standard question that gets asked. This is a process related thing. Now, many companies, and this is around the world, it doesn't matter big or small, functional testing is being performed every time, is being performed by developers. However, security testing of even a small code change that gets deployed, of a small code change deployed in production, is not carried out. In production is not carried out. That's a problem. So this is a process related issue. Okay? Whenever you carry out a change, you make some changes, you have done some functional testing, and then when you move to production, how the code performs, what functionality is it performing, that is getting tested. But are the companies performing, or the people in those companies, are they performing security assessment of that particular change? The most likely answer is no. Okay, so I think somebody has talked about SAS testing, which is code review and all that. Fine, fair enough. Let's talk about this. Now the question is, if you carry out, let's say in a year, if you carry out up to 200 code changes, you start adding new features every day. The point is, are you going to carry out a security assessment like a code review every time? Or are you going to carry out a dynamic, just while executing, are you going to carry out every time? See, carrying out once in 6 months and carrying out every time, there is a big difference when we're talking about it. So a company may perform a source code review, which is similar to your static testing. That will get that with the help of certain tools, that will get performed once in 6 months, but it will not get performed every time. That's the point we are trying to convey here. So this is where the underlying problem is from a process perspective. Okay, this is the underlying problem, that the code change is not getting reflected every now and then. Okay, you're not performing the security assessment every now and then. Another factor is risk assessment. Any code change that you deploy. So typically, whenever you raise a change request, what you do is, you would provide the change that you're making along with the rollback plan. But very few organizations provide the impact of that change from a security perspective. From a functional perspective, it is covered, but the impact of that change from a security perspective is generally missed out. So this is about, these are the kind of issues that you deal with. Another catch is, if you go through a tool like Cloudsploit, if you go to the GitHub page there, this is how it works. So for instance, if I have to check out for my payment card industry controls, or I want to check out for Center of Internet Security related controls assessment, if I want to find out if I'm running on public cloud, and if I want to find out what is my security apparatus, how does my security look like, what are the vulnerabilities or what are the risks from a PCI standpoint and from the standard top 20 Center for Internet Security related controls, how soon can you find that? So with the help of tools like Cloudsploit, you can actually turn this up. If you check out the GitHub page, and sometime I'll show you a report on this also. So when you deploy this, they have some parameters that tells you they have compliance with PCCI or HIPAA, or compliance with CIS, Center for Internet Security related controls. So I can set up my AWS, I can integrate with Cloudsploit, I can integrate my Azure environment Cloudsploit, and then get a command line listing of what my compliance posture is. And from these standards perspective, and to what level, to what extent do I see risk? And this is an example of a cloud access security broker. Okay, there has to be a policy which sort of change requires security assessment. Yes, a company should have a change control policy. So any company would have a change control policy. Okay, every company would have a change control policy that simply indicates what to do whenever you have a change. Now, for instance, I'll show you a risk assessment policy that I had drafted. Okay, take a look into that, and then you will be able to identify. So, for example, this is a risk assessment policy. Okay, so what does risk assessment process include? Identification of threats and vulnerabilities, identify all vulnerabilities associated with each asset, check out the impact for each of the vulnerabilities. So you can describe, the impact level, the likelihood of that. How do you provide a risk rating for a specific vulnerability? And what's the way to remediate? What are the kind of security controls you'll deploy? Or are you going to abandon that activity altogether, a process altogether? Or are you going to buy insurance against it? Or are you just simply going to accept the risk altogether? So that these are the kind of things that actually work. Yeah, they are deployed in your risk assessment policies. And similar to that in the change control policy or the change management policy, that was actually a good question. You would document different scenarios that, and you have to abide by what is documented in your change control policy. So this is the part that we covered so far. So your change control policy basically contains references, or it will contain guidelines as to, what should you be doing before you deploy a code change. Now, many companies would have this established in their this thing, but this is the point that I talked about, where performing a security assessment of a code every time when such changes are deployed in production environment. These are the kind of things that has to be mentioned explicitly in your either in your security assessment document or either in your change control document, that you're going to perform, from a change perspective, what's the impact of it. You can refer to this part. Okay, that being said, I think let's do one thing. Let's give you 5-7 minutes. Let's give you a 7 to 10 minutes break. After 10 minutes, we'll come back and we will then continue the remaining of the topic. Then we'll talk about log management. We'll talk about, in the meantime, I'll try to pull up the checklist, that you go through when you answer various questions. And I might even share that. So let's take a 10 minutes break. And then when we come back, we will resume this part. Okay. All right. So typically whenever I conduct an audit, these are the questions that we ask. Okay. So for example, you can see that there are different areas: application interface security, audit and assurance, business continuity, planning. Then you go towards change control and configuration, data security and information lifecycle management. Then we go towards data center security. Then we focus towards encryption and key management, governance and risk management. It just goes on. And then it comes to human resources is just a normal thing. Identity and access management, related areas, infrastructure and virtualization security, interoperability and portability of your systems and environment, mobile security, and this is endless, right? For your forensics, security incident management, e-discovery, cloud forensics. So it deep dive into many areas, antivirus, software vulnerability management, threat and vulnerability management. So this is a checklist. So for instance, just to make it easy, do you use manual source code analysis tools to detect security defects in code prior to production? Now, for my organization, this is a no. So they're not doing it. Now, we run security tests once in 6 months or once in a year, the external ones. But even if are you doing it that internally? So now we are including a provision for whenever there is a change, it should be prior to production, it should be done. Do you review your applications for security vulnerabilities and addresses any issues prior to deployment production? Then we talk about, does your audit program take into account effectiveness of implementation of security measures? Do you conduct network penetration tests of your cloud service infrastructure at least annually? And this is it just goes deep and deep. So I'm just trying to showcase you, what are the areas. And then I'll also walk you through a vulnerability report. Do you share your business continuity and redundancy plan with your tenants? So now the quick pointer here is wherever there is a no, okay, all the no's are to be documented as a risk in your risk register, something that I showed you earlier. So a SOC team gets into these areas also, SOC team definitely gets into these kind of areas. Our policies and procedures established for management authorization for development or acquisition of new application systems databases? Do you have controls in place to detect source code security defects for any outsourced software development activities? And do you provide a capability to identify data and hardware via policy tags, metadata, hardware tags, etc.? Now, these days, one specific area is taking, it's generating a lot of interest specifically, and this is applicable here also. When we talk about encryption and key management, right? Encryption and key management, whenever we talk about it, typically with public cloud vendors, okay? Typically with public cloud vendors, you are storing them, you're storing these keys with Amazon itself or with Microsoft itself. So you are generating the keys and storing it there itself. That may not be a big risk, but it is still a risk, because you are at the mercy of a provider. If there is some malicious person sitting in the provider's infrastructure, if that person gets hands to your keys, your encryption keys, that person can decrypt the data, and he can smash your data. He can literally delete your data. He can do anything. So to deal with this factor, nowadays, even cloud vendors like Google, what they have done is they have started to introduce external key management. So you generate your keys, you secure all the keys, you secure your data with the keys, and you store your keys, with an external vendor. So this is also referred to as hardware security module. Okay. So who are the vendors in this space? You have vendors like Thales, you have Photonics. So you can store your keys outside that. So this is big. This is also a part of your. So if you are dealing with an external key management solution, your SOC team, your teams can also take care of that part also. So however, this is discretionary. Your application teams may, if they want to have control over key management, they too can manage them on their behalf. So these are the kind of issues that we encounter, or these are the areas that we basically get around. And then when you go through security assessments, these are the kind of questions that you get asked specifically. Do you have a process to conduct risk assessments annually or after a major change in IT or business? What physical logical security controls do you have for data center security? Do an inventory of this thing? Do you have a patch management process in your organization covering all assets? And do you perform continuous vulnerability assessments and remediation program? So all of those things. So typically for your compliance, and when as an external audit, whenever an external audit happens, just for your reference, just a quick thing. So typically whenever you go through a audit, okay, let's say you might go through a compliance audit. Now this is a compliance audit typically. So they capture a lot of information. This is a typical compliance audit, right? And this is what are the kind of things they capture. And then we'll also talk about VAPT assessments. So they tell you that in 15 domain areas, you're compliant with some and you're not compliant with some. Okay. So you have risk management, you have the policy, you have the register, you are treating risks. So all these things, your risk assessment policy, they will talk about whether you have policies and procedures, patch management policy, how do you report your incidents, and how do you provide responses to that? All these things are a part. So whichever areas are non-compliant, sometimes specific areas will fall under the radar of your SOC team. Now, third-party inspections are definitely not a part of this, but they do fall under these kind of things. The other thing that you can take a look here is your assessment report. So let me show you. So this is the assessment report. Here we have certain things, medium risks and high, and all the risks are captured against your top 10 findings. And here we are talking about multiple sessions enabled. What is the thing? An email address disclosure, clear username. This has been fixed. Open ports and all those kind of things. Cacheable HTTP response. So wherever they feel that there is a vulnerability, what they do is they will tell you the recommendation, what you should do. You could deploy a captcha or something. So that's how it is. These are the so this is how you look out the vulnerabilities. If you see any high, medium, low vulnerabilities and the prevalent security controls, and if you see risks, you will start documenting those things in your risk register. And security operation centers, one of the core activities is the remediation of all these related risks. So I hope this part is clear. Now let's go back to our discussion. Okay. So these are the kind of things, and I'll share this context. Now, before we move further on the slides, let's just give you a background of what are the things that are going to be covered in this course. Okay. So we will continue to discuss on SOC, but along with this, what are the things that at least on the practical side of things. So vulnerability management will be covered. Okay. We will go through threat hunting. Specific use cases of SOC will be covered. You will do network forensics. Okay. We will do what are the other things that we'll do? Forensics. This will be covered. So just to make sure that everybody is on the same page, just to give you a background. So you will cover this. We will look at how to investigate incidents, security incidents. How do you investigate them? Analyzing logs, analyzing your logs. This will be covered. And we will be covering remediation of risks or vulnerabilities. So we'll take some examples of remediation of security risks and vulnerabilities. That will be covered. Okay. The 9 point could be so this is purely from practical aspects, what all things will be covered. So you talked about vulnerability management, implementation of your SIM tool, obviously, because if you are doing how to configure intrusion detection rules, configure into IDS rules, and how to detect security threats, how to detect threats. So this is what we'll be covering. What else apart from this? So vulnerability management, specific use cases, SOC, investigating incident, analyzing logs, implementation of your firewall, because you first need to understand how to analyzing and how to evaluate audit logs and deploying security controls to mitigate weaknesses. So we'll take certain examples, talk about this part. Okay, weaknesses. So I think more or less this would be the entire structure of your from a practical perspective. This will get covered. So we have forensics also. We have talked about malware forensics, how to detect. So malware forensics also, detection of malware. So I mean, so all these kind of things will be covering in your syllabus. Okay, all these areas will be getting covered. How to implement a firewall, how to implement a IDS device, how to analyze them, all those kind of things, along with setting up a SIM tool, analyzing them, how specific use cases that we can explore with the SIM tool, vulnerability management tools, all those kind of things, threat hunting, all these related areas. So these are the areas that will be getting covered as a part of your practical aspects. So this is what I see at this point in time. Okay. Yeah, we'll talk about the MITRE framework, all these MITRE attack framework and all that will come in the next subsequent part. Okay, we will follow that as we move along. Okay, so MITRE attack framework and other frameworks, some of those things we'll talk about in our subsequent sessions. Okay, I'm just talking about from a practical aspects what all things will be covered. Okay, so we'll come to that. Don't worry about that part of it. I think there has to be a structure, there has to be a flow. So think it will be along these lines. Okay, and the last part would be monitoring tools. So those things also will be covering network monitoring tools. So there are some books. I won't say that I'll share a good book with I'll share a link of SOC book. There is a specific book by SOC book by Omar Santosh. So you can take a look there. Okay? Just try to take a look there by Omar Santosh. So that would cover this part. Now, let's go back to the slides. So I've given you a perspective of what are the things that we'll be covering from a practical aspects: vulnerability management, threat management, mitigation of vulnerabilities, all these related areas, analyzing logs, all of those things. The log management, I think this is a very important exercise. This is an important part. So I've given you various contexts, and let's talk about, because log management, please understand that it's the core of your SOC. What are you going to investigate without logs? So your log management becomes very crucial. So as a SOC analyst, you should be aware about log management. Let's start covering that. Okay. So let's cover this part. So I think we'll quickly walk through this part. What are the important areas that we'll cover here? Now, what kind of logs I have showed you, earlier already that we have different kind of security devices. We have different kind of security controls. So they all generate logs. They all generate events. So we are talking about investigation of those logs. And at the same time, you can still get you can also directly get your, system logs like your Windows servers, your application server, database servers logs that can also be analyzed, by SIM tools. Now, log data. What are the kind of logs that we're talking about? We're talking about audit records, transaction logs, transaction logs of databases. For example, somebody somebody dropped a table. Who dropped the table at what time? That is the kind of information that is so critical in your transaction logs. Do you see any alerts, intrusion alerts, kind of connection logs, user activity logs, various other alerts and messages? And what are the kind of devices that are generating these kind of, your firewalls, your IPS, IDS, routers, IDSs, business applications, VPNs, antivirus, next generation malware, anti-malware, your proxy tools, they all generate these kind of logs. Now, why? Let's understand the why of security analysis. Why do we do security analysis? So it helps, it gives you, it provides, situational awareness and new threat discovery. See, we get so many log files, we get tons of log files, but the core challenge is, if you are getting 10,000 log files, how many can you analyze individually? So there's a question mark, right? So you need first of all, you need to get all your important logs at one centralized repository, and you want to check out for specific events. For example, any bad IP addresses, any IP addresses that are known to be, bad actors. So those specific IP addresses. Are you seeing any traces of a denial of service attack? So conversion of the data, which is there in the log files, you want to get a graphical representation of that, which makes it easier for you to analyze what's happening. Measuring security, tracking what the users do, incident report response, all of these things are a part of your log analysis. Now, I think this slide is a pretty straightforward slide. The hackers probably wouldn't want to, they don't want to set up a TCP three-way handshake. So they don't really follow those protocols. They really want to make sure that they don't leave any traces. But that's okay. The whole idea is that your logs, you are on the defensive side of the things. So you want to see if there are any attack related traces or any specific anomalies that you see in your log files, any specific events that are worth investigating. Now, if you do a manual analysis, which is not the way, you can do a tail or, tail, and you can check out for certain conditions. You can filter logs, you can check out for positive and negative events. You can get a summarized report, or you can just have a simple visualization of this. And correlation, which could be based on, you can correlate your entries in logs. That could be based on certain rules. For example, if you have configured a rule in your IDS, intrusion detection system, that all any connections that are coming on port 3000, they are to be dropped, or they have to be logged. So they have to be logged. And you may have also set up same rule. Any connect on your IPS, if there are any connections coming from port 3000, drop the packets. So what are the things you do? You collect the logs, you centralize them securely, you analyze them. Once you analyze them, then you can send an alert. There may be certain events that may generate alerts, or you could share them with others in your teams. You can then store securely all these logs once you've analyzed them, and then you can report your findings. You can report your findings to your senior management, which would be your CISO and other top your CIO and other top executive management. Now, why log management? Because logs go beyond security. It gives you idea regarding threat discovery. It also tells you if your users are compliant with internal security policies. It can help in incident response, forensics. If there is any specific entry that you're trying to locate, it can help there. Logs are very helpful for troubleshooting purpose, and also they may indicate any performance management metrics. Now, how do you comply with logging standards? So what typically we do is, if you're working with a lot of these tools, we convert audio, because logs come in different formats. So we want to eventually get a format which is human readable and something that makes sense. So either we convert the existing logs into a syslog format and then read those logs. And why logging standards? Because you need a common language so that people and others can understand what is there in the logs. It is easier to report on logs and explain the reports. The logs can provide a deeper insight into future problems as indicated by the log data. And it also provides for easier system interoperability, because why does it provide that? Because there may be hints of certain problems that you can see before the system crashes, and common logging practices simplify audits and compliance. Now, I don't think we'll cover NIST. The whole idea is that you should be aware about what NIST 892 is all about. It's a special publications. It serves as a guide to computer security log management. It provides you guidance as to how to implement your log files, how to rotate your log files. It tells you the best practices for dealing with your logs. So that's what it just tells you. And NIST 892 is very effective. So if it is adopted by any company, this is a self-adopted framework that can be adopted by companies to improve their overall posture. I think we can skip this slide. So computer log, is nothing but a record of all events occurring within the organization systems and networks. And within an organization, many log contains records related to computer security. So for example, they may contain traces of a DOS attack. They may contain traces of repeated attempts coming from a particular IP address. So your log sources do not only contain your system related details, but they also contain a lot of security events. And that's the whole goal. This data, log data, is worth weight of gold for security people, because from there you can analyze any traces of any related problems. Now, security log management is the process of generating, transmitting, storing, analyzing. Once you have consumed the information, then you are good to dispose of the log data. Now, what are the benefits? It helps to ensure that computer security records are stored in sufficient detail for an appropriate period of time. Routine log reviews and analysis are beneficial for identifying security incidents, policy violations, fraudulent activity, and operational problems. And logs can be very useful for performing auditing and forensic analysis, something that we are going to do subsequent interactions, supporting the organization's internal investigations, establishing baselines, and identifying operational trends and long-term problems. So logs can be very helpful. So one of the reasons why there is so much impetus and so much focus on your logs, because of a variety of things that you can do with them. You can premeditate if there are some secure that you can see some traces, or you can get some hints about a security attack, or sorry, an attack that might happen in the future. So you may get some hints related to that from reviewing the log files. It may also reveal that the log files might also reveal if there are traces of DOS attack. They may also reveal if there are any anomalies happening, and even for the auditing purpose. So routine log reviews and analysis are beneficial for identifying security incidents, policy violations, any fraudulent activity, and operational problems. And you can also perform auditing and forensic analysis with them. Now, one area where you got to be very clear is what kind of logs. Security logs that are coming from firewalls, from IDS, IPS, that is coming from your web application firewalls, they are different from your normal application logs. So they are a lot different. You can still get your Apache logs or any application logs also for analysis, but there is a key difference between the logs that are coming from security applications. But security applications will only log security related issues, or they will only contain security related events, whereas your application logs will contain all kind of data. It will contain auditing data. It will contain what operations were performed on that application. It may also contain certain events, like if a shutdown command was given on an application. It may also contain security events. So we need to distinguish between, when you do log analysis, the methodology that is used for analyzing logs coming from security applications is a lot different that's coming from normal applications. Now, what are the challenges also? There are several potential problems with initial generation of logs, because the major problem is that logs, different applications have different ways of generating logs. So you need a common format, right? And that is why sometimes what you do is you get those logs converted with the help of certain tools. You can get the data converted into the logging data, get converted into syslog format, which is a universally accepted format for logging data. Secondly, sometimes what could be happening is The confidentiality, integrity, and availability of logs could be breached inadvertently or intentionally. Now, I'll give you a practical scenario of this. Okay. See, when you do OS auditing, operating system auditing, okay, a lot of focus is on the ls-ltrh command, because that tells you when was the file last modified. Okay, so let's say if you're doing, let's say you are on a particular directory, okay, and you issue a ls-ltrh command on Linux. Okay, if you issue this command, it will tell you the timestamp of the file, when the file was last reviewed or modified, it will tell you. So for instance, if you do a touch-t, touch command is used to generate a new file. If you do that, and then you provide a timestamp on a file, let's say the file name is abc.txt, whatever. So that generally it's txt, abc.txt, whatever. This T command is a very useful one, okay? So I can change the file timestamp to something like 2016, or let's say 2022. Let's say the month of the year, which is February 02, and then 27, and then I modify the time to be around 6 a.m., 6:05 a.m. So it's possible, okay? Yes, touch command, you can change the, with the help of touch command, you can change the file, okay? With that, yes, with the touch command. So touch-t. So if an auditor were to see, if that person does an ls-ltrh, file will not be empty. No. If you use a touch-t command, the file will not become empty. Okay, so please that if you just issue a touch command, then the file is empty. If you issue with certain variables, how about NTP sync issues? No, I don't see any issues with NTP here, because all you're doing is you are just changing the file timestamp. So whatever is there within the file, those time slots, you're not changing that. So Shriram, that will not be affected. Okay. So please make a note, with the help of touch-t command, you can actually change the file timestamp. I'm just putting this command, and this way it's an easy bluff. Audit log capture would be difficult, Mr. Kofi. So I think in the audit log capture, that will be difficult. So the problem is that many times system administrators, they carry out all these maintenance operations. So they're opening 20 to 30 party screens in a day, okay, at a single go. So anybody can make it's not a deliberate mistake. It's genuinely someone might have made a mistake. And if they're worried that they will be caught, they can do things like this. So to avoid this scenario, what you could do is you could set up a process whereby, you could transfer your log data to syslog servers. So you could just do that, syslog servers, or you could create 2 copies of log files, could create duplicate copies of every log file, okay, whereby one file is kept on the server itself for troubleshooting, because the administrators would need that, and the other one is, and the replica copy goes to the syslog server. So in this case, the person will be caught up, because if they do something like this, while they can modify it on the server, on the replica copy, they would find the corresponding team, or any person could find the shutdown command entry. So you could create 2 copies and just distribute it this way. You could set up an automated process that whenever a log file gets generated, that moment itself, a process will run, a shell script will execute, and that will make a copy of this file on the syslog server. So by doing that, it's an effective way to, yes, you can set it up in a cron job. You can set up a shell script in a cron job, which can actually transfer the contents of the log file to another location, like a syslog server. So administrators are doing things like this. The other thing that you can do is, where this part comes into play, your FIM, file integrity monitoring software. That is very useful, okay? Now what it does is, your FIM tools, file integrity monitoring tool, they will capture a hash value of every file / directory in your system, in your server, okay? So probably you would have a process whereby every morning and every evening, you are collecting the hash values, capture of, every file, and you generate a hash value for every file, okay? A hash value for every file. At a later stage also, you generate the hash value. If the file contents are not matching, even if there is a single command missing, or even a single alphabet missing, the hash value will change. So you can take a look into those two snapshots, and that can tell you clearly, if the hash values are not matching, it's a clear indication that the file has been modified. So you can install tools like Tripwire. So for instance, you will be more interested in server logs rather than normal logs that are going to local machines, or they are going to the local directories. So this is something that is based on purely what you define. However, please make a note that not only these logs, but sometimes you will have to convert the log format to a syslog format or to another universally accepted format. Okay, not all logs that are getting transported, they will be in a common format. So you got to convert them using the same tools for, they're basically used mostly for security operations. Okay, while you can analyze, with the help of the query languages which each tool offers, you can analyze why the systems, you can get some insights, like the server went down. But we need to understand that there is a subtle difference between monitoring for security threats and monitoring of specific or diagnostic information, right? So if you want to diagnose information as to why your server, why the shutdown went, why the server got shut down or something like that, that's more from a diagnostic point of view. So you possibly on your Linux systems, you might get you can run certain tools, from which, you could look at your kernel entries. You could look at, there is a specific command which I'm just forgetting. So you can use something like this dmessage command, okay, to find out if there are any, issues that can give you clues as to why the server went down, or they could be crash dumps, in your temp folder. You can investigate that, or in var/log location, you might have crash dumps that can be investigated. So I think that investigation is a lot different than capturing information for security events, I think.
Just a quick info, guys. If you want to make a career in cloud and DevOps, then Intellipaat provides an advanced certification in cloud computing and DevOps by ENICT Academy IIT Roorkee, and it is taught by IIT Roorkee professors and industry experts. This course is designed to help you upskill and land in your dream job.